With a couple of exceptions, this worksheet should have been pretty straightforward because mostly you're entering numbers and doing quadratic regressions over and over again. So the first one, it asked you to find a quadratic regression for the relationship between the horizontal distance and the height of a ball. And on these, what you want to do is type in these numbers into list 1 and list 2. Can anybody tell me what you got for your quadratic regression for number 1? So I'm going to ask Hollis, what did you get? And basically that's exactly what I have. Yeah, negative 0.11 and some change, negative 0.118x squared plus 2.112x plus 4.215. Sounds great. The second question asks you, when is the ball going to reach its maximum height? Now, you could do a bunch of things with this. I mentioned yesterday that those of you that go on to calculus next year, we're going to be learning exactly how to do that very easily in calculus. And like these guys will be doing that second semester in calculus. But there is a much easier way to do that just looking at this data. You notice I highlighted a couple of things on the screen here. And I did that because it's pretty easy for me to figure out that around 9 is when we're at our maximum height. Does that make sense to everybody? And that's why I would probably say around 9 feet is going to give you the maximum height that you would end up having here. And just kind of using your common sense on a few of these problems can help you out a little bit with that. You go on to the second one, it asks you to again to find the equation, and then we're supposed to figure out a population in 2020. So let's see, Ava, do you have an equation for number 3? And she again copied off me, I think, absolutely. So yeah, 12.209x squared plus 12.999x plus 504.257. You had to figure out the population for 2020. Now, the thing that is actually probably most important on this one is that it talks about the years since 1970. How many years after 1970 is 2020? And that's why we've got to plug in 50. You don't plug in 2020, you plug in 50. And I did that and got like 4176.7 approximately. So it's that many thousands, which would be like 4,176,000 is roughly what you're going to end up having for a final answer. We okay there? So the city we're talking about must be something like Los Angeles here. Third one asks you, number 5 here asks you, what would be modeled by a quadratic function? So quadratic, again, means x squared. That's the important thing in it. And if you look through this list of things, there is one of the things they're talking about where, like, the formula to find it involves squared. Which is which one? Xander. It is B, it's area. If you find the area of anything, you're dealing in square units. Circumference and diameter both are just lengths. And the diagonal of a square and the side of a square are both just lengths. So that's not going to change. The volume, you end up cubing how long a side is to figure out the volume. So that would end up being a cubic function. So B is actually the answer to this problem. And that is what it's going to be. Number 6, what I did was find an equation and then I plugged in 6 to figure out what was missing. I took the other numbers and found a function which happened to be 0.5x squared plus 5x. And when I plugged in 6, I got exactly 48. So that was my answer. And D would be the right one. Number 7, you can do basically the exact same thing. You can find an equation based on those, which happens to be like 1/3 x squared plus 5x minus 8. And when you plug in -3, you get -20. So C would be the answer on that one. So number 8, you notice I highlighted the shapes again. You could do this problem by literally taking all of the dots they have graphed there, putting them in a list and generating an equation, which is not actually going to look a lot like any of the equations they have there, because theirs would be multiplied out with x squared, x, and a number. What's really much easier on this is to think about what we did in the last chapter when we were moving around functions to different places. This is going to be a function that's based on a parabola, but the reason why I highlighted all of those dots is it's looking to me like the vertex of this, the bottom of it, would be somewhere around the point 3, -4. Do you see where I'm getting that looking at where the parabola I highlighted on here is going to be? That's why, if you remember how we did the stuff in the last chapter, the correct answer on this is going to end up being A, because that's the one where you do the opposite for the x and you do exactly what it says for the y. So x minus 3 in parentheses squared and then -4. And that is the only one that actually makes sense for exactly where the vertex of this would end up being. Okay. Now, again, there are other ways you could do it, but that's by far the easiest way to do that one. You see what I'm talking about with that? So number 9, again, we're trying to figure out an equation. And again, there's like an easy and a hard way to do this. I actually did figure out where all those points were, and I went to my lists and plugged them in and got an equation that wasn't any of these, but it was actually closest to D. And D is going to be the right answer, by the way. Something else that's kind of important on this, though, is that you could at least narrow it down to a couple of choices by looking at what the parabola they have graphed there looks like. And if you realize one thing about it is, first of all, it's an upside down parabola, which means it has to have -x squared. And that means there's no way it could possibly be A. I also know that if I look over at the left-hand side of this, it's going down, but the y-intercept for it is going to be somewhere around -10. It's not going to end up being at like -32, which is why D makes a whole lot more sense than C. Now, I actually still haven't eliminated B as a possibility, but what would happen if it were B is it would be going down faster than it is. It would actually be a little bit narrower parabola. When I actually put all of the other numbers in there and generated something, what I got was -0.886x squared plus 7.125x minus 8.633. And again, what I'm doing is looking at what's the closest to that, and it is D that has a positive number by x and fairly close to -8.6 for the y-intercept for the other side of it, which would be what you get if you plug in 0. Now, if you didn't get that one, honestly, I don't really care a lot about that one problem, but that is how you could figure things out with it. The last 4 are all pretty straightforward and easy, because these, you just have 3 or 4 points, you plug them into your calculator, put the x's in list 1 and the y's in list 2, and calculate a quadratic regression. And like on 10, I got 1x squared plus 2x minus 8. On 11, I got -1x squared plus 8x minus 7. On 12, it's 2x squared minus x plus 3. And on the last one, I got 1x squared minus 12x plus 22. And those all come out to be exactly whole numbers. So any questions we have with them? Okay, so today we're going to do sort of a review sheet that ties together all of the stuff we've done with various correlations. And you might have noticed up on the board it says we are probably looking at a test Friday, which of course means we'll be reviewing and tying everything together tomorrow and making sure that you know what you're doing with that. So the review sheet will hopefully prepare you for that test.